All right, well, oh. What is that? All right, well, I'm gonna go invite students to join, so just hang out for a second. And I don't really feel the need to, well, whatever. We'll get this going. Was that what that was? Oh. I'm there now. What is that? I can hear someone. Who do I got? Oh, I got a couple of you. Oh, well, I was about to email you back, Louisa, but apparently I'm not going to now.
I have a question.
Okay.
It's the number 27 with the prince.
Yeah, we had a lot of fun with that one in face-to-face review.
Yeah, well, I got the answers because I went to the review, but I don't, is there like an equation to it? Because I tried to do like 46 minus 22 is 24, and it just went like, it's like 3 and then 6 and then 12 and then 24, but like I couldn't figure it out, like an easier way than, like if there was like an equation, I feel like there's like an equation to it. I don't know.
I mean, we can write one. It's not going to be pleasant. With something like that, you're more wanting to do a problem-solving strategy, and that was really the intention when I put it on there, was to really make you think creatively rather than force you to write some sort of equation. I mean, if it makes you feel better, we can try to write something.
Well, I don't care like what it is. I'm just trying to like figure it out like the easier way. If you have an easier way, then to do it. Like I guess like illustrating it, or I don't know.
Well, I mean, it's kind of hard to prepare students for a problem-solving, like a situation where you have to be creative. I mean, I'm basically, because what you're going to see on the test is not that. So
Are
the
we
first
gonna have
problem,
this question in the test?
you're not going to have the Prince problem, but you're going to have a problem where you have to
Work
think about it,
backwards.
work backwards,
Oh
and think
my.
creatively. So it's not that there's a set equation that you can look at. You just
Oh,
got to be creative and not give up, I guess.
okay.
I mean, do you want me to? We can try looking at it.
Yeah, is there like like just like a way of explaining it or a little bit more into it? I don't know.
Let's see. Does everybody see my screen?
No, we can't see anything.
Really? I was so excited. Okay.
There it goes.
Oh, there it goes.
Mhm.
Okay. Now can you see my screen?
Yes.
Yay. Okay. I'm going to try a different approach this time. Last time I've been using where I type it out. This time I got my tablet out so I can write. We'll see if that makes this a little bit easier for us. Okay, so we got we have this print, and the first, see if I can get some space to write here. Okay, so the first time, so he's got X number of bags of gold, and the first bridge he goes to, the guard says, I want you to give me half of what you have plus 1. Okay, so that's the first guy. And then he gets to the second guy, and the second guy says, I want you to give me half of what you have remaining. So what does he have remaining? He has that. Let me kind of get here. He's got 1/2 of the x minus 1/2 x plus 1 plus 1. You kind of see how this is going to get unpleasant here in a moment.
Yes.
Because if we go to the third guard says, I want half of what you have plus another 1. Well, half of what he has means we need another 1/2, and we need that big brick of, what is it? All of that. Let's see, and then Okay, and then plus 1 there. So, anyways, as you can see, you could distribute the 1/2 in, and you could combine like terms, and so it is possible to solve. It's just not a pleasant experience. And so the easiest way to go about doing this particular question is to work backwards and kind of think, well, he ends up with 1, so the previous guard, he must add 1 and then double it where you get the 4. So, sorry, don't have an easier way to go about doing that.
It's okay.
Yes, I'm having a test of it. You want me to turn my webcam on so people can see you in your pajamas? My son just thought he'd check and see why Dad was talking to nobody. Anyways, another, or do we have another question I can go through? And you guys can type in your questions if you want. Or I can just shut off everybody's mic, or I mean, what would you like to talk about?
What about the unique fraction?
You're just picking all the fun ones.
Yeah.
You want to, I mean, I was thinking in face-to-face we talked about we can be creative and sort of guess some fractions, or I showed this algebra process that everyone didn't like, but oh well. Let me go back to that one.
I had a question because it said like when we did when I was trying out to do your way,
Okay.
you put x over 2. Why did you pick 2 instead of doing 1, 2, 3, 4? You did like x over 2, x over 3, x over 4, x over 5. You didn't start with 1. You went ahead and went 2 and so on.
Well, I picked 2, 3, 4, and 5 as the denominators. And the reason why I didn't pick 1 is if you put x over 1, it's not a fraction.
Okay.
That's a whole number. So I wanted to make sure that I had 4 fractions.
Okay.
And so that would guarantee that would happen. Now we can kind of troubleshoot this one. So let me kind of. So think of the test review. We talked about how it's not really going to be 2. It's going to be 1.
Mhm.
So if I said 4 unique fractions that add to 1, right? Can we creatively think of them, or do we have to go through the little algebra process?
It doesn't matter.
Doesn't matter.
No, I think no. Just try the problem, because what if you change the numbers or like the ways of unique?
Right. Okay, so I would say, I mean, we just kind of pick denominators that we're happy with. And I think 2, 3, 4, and 5 are the smallest that we can go with, but we could pick 11 or 13. I mean, we could pick any number we wanted. So if I did x over 2 plus x over 3 plus x over 4, I'm assuming everyone can see this. Can we see me right? Uh-oh.
They wrote yes.
Okay.
And Diego said he can't.
He can't?
Yeah.
That's weird. How can some people say, okay. Diego, I don't know why you can't see it. That's weird. Why would everyone, okay. Diego, try clicking on my pic. Try clicking on me. Try clicking on Peter Soleil and see if that, you might have clicked on someone else's icon and that overrides whatever I picked. I don't know. Maybe it works, maybe it doesn't. All right, so I'm going to keep going with this one. So I'm just going to do a common denominator with all this. and the common denominator is going to have a 2, 3, 4, and 5 in it. And actually, I could do least common, because if there's a 4 in it, I know there's a 2 in it. So if I just did 4 times 3 times 5, that should be enough. And then for the 2, how do I get the x over 2 to say x over something over 4? Well, I multiply that by 2. That might be pushing my luck here. Okay. Let me try not to be so abstract for a second. Let me just convert them all to the same number. What is that? 4 times 3 times 5. So that would be 60. Okay, so if I make x over 2 say 60, that's 30x over 60, reduces down to x over 2. If I make x over 3 say 60, that would be 20x, because that reduces down to x over 3. Let's see, this one, x over 4, what would that be? That'd be 5, 15. And then x over 5, so that would be 12. And all that equals 1. Okay, so then I want to bring them all together. So 30x plus 20x, that's 50, plus another 15, 65, so 77x equals 1. And so x, if I multiply by 60 and divide by 77, then I end up that this numerator has to be 60 over 77. So in this case, it would be 60 over 77 over 2 plus 60 over 77 over 3 plus 60 over 77 over 4 and then over 5. Uh-oh. My OneNote has stopped. All right, hold on. It's going to restart. It's coming back. Come back. Press Enter. Oh, how far? What did it erase? What did you take away? Oh, the whole thing. Oh no. Okay. So it was x's was 60 over 77. So that would have been 60 over 77 over 2, and then that same fraction over 3, and over 4, and then over 5. And then I can simplify that, so that's 60. Actually, 62. So that'd be 30 over 77. The 3 goes into 60 20 times, so 20 over 77. That goes in there 15 times. And that goes in there 12 times. And so I have a group of 4 unique fractions that add to 1. If that makes sense. So.
Yes.
Okay, anyway, so that trick will always work. Or you can think creatively and just start guessing numbers, and maybe you get lucky and find something.
Okay, so it's better off to start off with the 2 and not use 1 in the fraction, right?
Right.
Okay.
Because if you use 1, you're saying one of your numbers is going to be a whole number.
Okay.
And you don't. I mean, it might work and it might not. It just depends on how the numbers work out for you.
Okay.
All right, and this is cool. My phone is now saying someone sent me a message. Okay, so let me run over here. Okay. All right. What else can I help out with? All sorts of fun. Oh, 19. Okay, okay, good. Yeah, Eddie got a question. Yay. Okay. Let me jump over to 19. And Louisa, I'm gonna mute you because I'm just rude like that. So Eddie, if you want to turn your mic on, you can talk. Otherwise, it's just gonna be me talking.
You talking's fine. I just, like a whole general how to do the whole problem thing.
Okay. Let me go get 19. Oh, this guy. Okay, so the idea on number 19, you're not going to have this question, obviously. You're going to have some other teaching scenario where the student makes a statement and then you have to decide if it's correct or not correct. So in this particular question, student claims that subtraction of integers is commutative. She says that, for example, if a and b are integers, then a minus b is equivalent to a plus negative b, and that's a true statement. So since addition is commutative, so is subtraction. What is your response? Okay, so this is something you're going to have to do as a teacher. Someone's going to make us say something in class, and then you have to decide whether or not what they're saying is correct. So the question really comes up to, what are they claiming is true? Like, are they trying to claim that a minus b is equal to a plus negative b, or are they claiming something else? And the answer is it's something else. That they're claiming that it's commutative. Okay. So in the problem, do we have an example of something that's commutative? And we don't. We have this statement right here about integers that actually is true. That's what a minus b means, is a plus negative b. So the appropriate answer is, well, no, subtraction is not commutative. For example, pick two numbers, 5 and 3, and let's illustrate that. So if I take 5 minus 3, it's that area right there, that is not the same as 3 minus a negative 5. However, if I do convert this to addition, then that addition is commutative, but the 3 still maintains its negative. So because right here, when we convert it to the addition statement, we're actually going into addition rules, in which case addition is commutative. But when they said the original statement of 5 minus 3 is not equivalent to 3 minus 5, then that's actually false. Okay, so let me kind of recap this and what you would want to do. So on the test, you're going to have some sort of statement dealing with properties, and you have to decide first, is it even true? And if it's not true, then you have to come up with a way to illustrate how you can demonstrate that it's a false statement. And you don't have to be complicated. It wasn't hard to go, let's just pick two numbers and show that it's not true in that particular case. And so that's all I was looking for, that you first understood what it was asking and then were able to come up with a way to justify why it's not true. Okay, that help you, Ed?
Yeah. I just saw it and it looked kind of complicated, but the way you explained it, it works out. I understand that.
Right. And the intention behind the question is, let's just throw some teaching scenario at you and go, hey, what would you do? And then hopefully go, oh wow, that's a good answer. I wish I'd have thought of that, because I'll tell you right now, there were a lot of times when I was teaching that I said stuff that I went, yeah, bomb that one. That was not a good idea.
Yeah, okay. So I totally understand that now.
All right. You got another one you want to look at, or?
Not at this moment.
Okay. I'll jump back and see if anyone's got anything else. Let's see. Go over number 4, integer multiplication. Okay, I can do that, Valerie. On you. Okay. Okay, so all of these, this whole first page, not just 1, 2, 3, and 4. The idea is I'm going to give you a abstract multiply and divide statement, and the expectation is that you can model it using either well, not either, but so under charge particle that you can actually handle that, and number lines you can handle that, and then you have to kind of remember the rules that work with those. And I think the one that I got asked in about number 4 is the one that I kind of feel like is the trickiest as far as how one would model something like that. And then the hint I'll give you is on the review, if it's a negative on the actual test, it's not going to be that case. It could be a negative positive, or it's not going to be a positive, I'll tell you that. There'll be a negative in there somewhere. So you kind of have to remember how you want to go about setting something like that up. So let's do something like 5 times -2. So let me just switch the sign and then talk about how on a number line I would go about modeling something like that. Okay, so when we multiply, the idea on the number line model is that the first number is a measure of the direction I'm facing. So because it's positive, so here's 0, because it's positive, I'm going to be facing towards the positive direction, and that's likened to that I'm going 5 miles per hour. Okay, so the first number tells me which direction to face. The second number we interpret to mean a time relationship. So in this case, the fact that it's -2 says I'm facing that direction to go 5 miles per hour, but I want to know where was I 2 hours ago. So in the past 2 hours, what number would I have been at? So an hour ago, I must have been at -5, and then 2 hours ago, I must have been at -10. And so that's where we arrive at that I went backwards in time to get the answer of -10. Okay. So like I said, you'll see. I'll change the signs up on you, but then you just have to remember what the interpretation is. Lydia, what is that? Okay. You can make me read. A recipe calls for a teaspoon of mustard seed, 6 cups of tomato sauce. Are you sharing me a cooking recipe? Okay, I'm sorry. It was not funny. All right, 2 tablespoons, blah, blah, blah. Take that as a 4th cup beans. If 33... Oh, Lydia's the one that's working. Okay, and that's fine, Lydia. You can turn yours on. To make sure I understand the question here. So if we use 33 cups of tomato sauce, how much are the other ingredients to make the proportions the same? And then 22. Okay, so we're going to have to... I need some paper. Let me grab this. I hope this is an actual problem. I hope you're not having me bake a cake later. And my son thought that was hilarious. Okay. All right, so let me get this down here. All right. I just need more space to write on. Okay. All right. So if figure out mustard seed. I don't know what that was. All right, we got mustard seed is a teaspoon, and tomato sauce starts off as 6 cups. What? Lady, I don't know if you can clarify that. Is that 4 1/2?
Yes, it's 4.5 tablespoons of the scallions.
Oh, okay. So 4.5. I guess I should be consistent where I'm writing these things. 4.5 of the scallions. And
8 1/4 cups of beans.
8 1/4 cups of beans. Okay.
And 3 cups of, or it says if 3 cups of tomato sauce are used, how much of the other ingredients should be used to keep proportions the same?
Okay, well, if you notice, to go from 6 to 3, you divided by 2. So in that case, you just divide everything by 2. So you'd have 1/2 teaspoon of the mustard seed. You'd have 2 1/4 of the scallions. You have 4 1/8 of the beans. So once you figured out what the constant proportionality is for one measurement, you just do the same for all of them. That's not 22 cups of scallions?
No, it's 2 tablespoons of the scallions.
Okay. Was it originally 4.5 tablespoons? Yeah, there's originally 4.5. Okay. So what proportion is it when we go from 4.5 to 2? Let's see. Well, clearly we got smaller. I'm going to come over here. 4.5 divided by some number gives me exactly 2. So if I can figure out that number, that's the same number I divide everything else by. So I'm going to just solve for x there. So 4.5 over 2 equals x. And then I just want to simplify that down. So 4.5, I'm going to rewrite that as an improper fraction. So that's 9/2 over 2. And then I'm going to bring down that other half to get 9/4. So I must have divided everything by 9/4 in order to get the 2. So this is going to be a little more complicated. Well, so the first one, see, for the mustard, I want 1 divided by 9/4, and that's just going to give me 4/9. So I got 4/9 of a teaspoon for the mustard seed. And then, I need some more space here. So then with the 6 cups, so the 6 cups of tomato sauce, so 6 divided by 9/4. Let's see, so that would be 6 times 4/9. 6 and 9, so I can take a 3 out of both of those. So that's 8/3. So we have 8/3 of a cup, or 2 2/3 of tomato sauce. I don't like that sound. Is everybody still with me? Uh-oh, what is that? What is going on? I don't know why it's doing that. Okay. And then 4 1/8 is the last one, so 4 1/8 divided by 9/4. And so that one, let's see, 4 1/8, I'd make that into an improper and then divide. So 4 times 8 is 32 plus 1, so 33/8 over 9/4 is 33/8 times 4 over 9. 4 goes into 8 twice. 3, I can take 3 out there, so 11 and 3. So 11/6, which is 1 5/6. This is an oddly specific recipe. Anyway, so almost 2 cans of beans. That's the answer. Almost 2 cans of beans. All right. Well, that was fun.
Okay. That's in the chapter 6 exam review.
No, that's a good question. I like that. I wish I had to put that on my my review. Good call on that one. Okay. Let me go back to the share room and let's see what we got going on here. That's it. It's supposed to be a happy face, right?
No.
Not a happy face. Okay. All right. All right. What else we got for me? Any other questions? Oh, 18. Hi, Karen. I'm glad you got in. I got all sorts of messages from you, so welcome to the party. Lydia, I'm going to mute you, and Karen, if you want to turn your mic on, or let's see. I don't want to eject you. I want to mute you. Okay. So, anyways, Karen, if you want to turn your mic on, then you can now do the talking with me while I jump over to 18. Or you can just listen to me.
Is it on?
I can hear you.
Yay. Okay.
18, 18, 18.
So it's on 2 fractions and 7/15 and 2/3.
Okay. It's a wonderful question. So you want to know the strategy on that one, or I mean, we can make up 2 other fractions. Let's do that. Let's make up 2 fractions, and let's find what's something in between them. So let's take something like 3/7 and 4, I don't know, 9ths. And our job is to find at least one fraction that's in between those 2 fractions. So what I want to do is I want to convert them to a common denominator, and then I just want to look at the numerators and find something that's in between the 2 numerators. So what would be a common denominator between 7 and 9?
63.
63, right. So I would take 3/7 times 9 over 9, and I would take 4/9 times 7 over 7, and that's going to give me 27 over 77, and that would give me 28 over 7. Did I pick one that really? Why would I do that? That's not cool. All right. Do you see the problem? I've got 2 fractions that there's not a distance of 1 between them. However, I've got a clever idea. I can find another common denominator between 70. In other words, I'm going to rewrite them as another fraction, and that fraction will have something in between them. So I'm going to take these 2 guys, and I'm just going to double them. And when I do that, that'll give me something. That should give me something big enough. So what is that? 54 over 154? If I'm wrong, please correct me.
Isn't the denominator 63?
Is it what?
63?
Maybe. All right, so that's still 126. Let's see. So here we got, 56 over 126. Hey, do we see a fraction in between the 2 of them?
55 over 126.
Yep. Anyways, so whatever 2 fractions I give you, just find a common denominator. And in the scenario where there's not a distance of 1, or there's only a distance of 1 between them, double them, triple them, just find another name for the fractions, and you should be able to find something that's in between the two. Okay?
Yes, sir. Thank you.
Oh, no problem. Let me go back to the main room. Okay. Thank you, Lydia. All right. What else would you guys like to see?
For question number 6 on the review, what's it asking exactly?
Okay. Let me jump over.
Is it asking us to prove that it's equivalent?
That didn't. Oh, there we go. Show me. All right. Hold on. Let me get over there. Number 6. Okay, yes. So the first page of the test is going to be some sort of teaching demonstration. So yes, they should be equivalent, and you're going to use the specific method of least common multiple to show that they're in fact equivalent to each other. So
Okay.
I'm specifically looking for that one technique. For whatever fraction I throw at you, and I'm not forcing any particular method on finding the least common multiple. I'm just essentially reinforcing that we just learned how to find the least common multiple on the last test, and I just want you to use it again to do this other skill.
Okay.
Do you want me to make up 2 fractions, or is that sufficient for you?
Yeah, we can go through a problem, I guess.
Okay. I don't promise it's going to be a pretty one. Let's see. So we just need 2 fractions that we relatively know are equal. I want to be really. Let's see. Let's go 1/3 and 5. Let's see, 5/15. So let's go 10/30. Yeah. That's a 10. Okay. So the least common multiple strategy, as I look at 3, and 3 is made up of 1 times 3, and 30 is made up of 2 times 15, and 15 is 3 times 5. So the LCM would be at least 2, because there's 1 2 in the list of factors. There's a 3 and a 5. And yes, I know it's 30. And yes, we could have all said that the least common multiple is 30, but I wanted to show you the technique. So then what I need to do is make sure they both have that common denominator of 30. So if I take 1/3 and I multiply it by 10/10, I get 10/30. And 10/30 is already in that least common multiple. So since the fractions match, therefore the 2 fractions have to be equivalent to each other. Sorry. The one on the test, actually, you have to think about. The one that I just made up is really obvious that it works, but anywho. All right, does that help?
Yes, sir. Thank you.
Okay. Let me jump back and see if anyone's got anything. Oh, okay. All right, so Lydia's asking about number 1. Let me jump over to that. Okay, so in the charged particle model, so I'm going to give you 2 numbers, and number 1 is going to be some add or subtract thing, and let's just kind of stick with the, let's do that. Let's do some positive numbers. So let's do 10 subtract a -3. Okay. So in the charged particle model, the idea of subtracting means I have to take it away. Okay. So what I'm going to do first is I start off with 10. So I'm just going to first build 10 of these pluses. Okay, so I got 10 of them there. Now, I need to be able to take away a -3 from whatever I've got written there. Now, I obviously don't have -3 to take away, but if I build in some 0 pairs, so I can always add 0. So if I add in, you know, a plus and a minus, I didn't change anything. I just added this extra plus minus there. But I'm going to add enough plus minuses that I now have the ability to take 3 away. So that's what I'm going to do, is I'm grabbing those -3, and how many pluses does that leave behind? That leaves 13. So that's the intention on that particular model, is if you're subtracting, you need to be able to take away whatever it is you're subtracting. So if you don't have what you need, then you might have to additionally draw that in to get it. I'm glad it makes perfect sense in all caps, so that's good. Anyways, what else? Who's the sunflower? Well, that's Karen. Okay. I see these icons. So, any other questions? Ask now. And if you guys think of anything, you can always just email it to me. The part where we just sit here awkwardly and stare at each other. I guess maybe I can ask, do we feel better about this unit? Does this seem like an easier unit for us, or we feel like this is like the hardest unit ever? I don't know. How are we feeling about things? Oh, the last problem. Oh, what? Can I show? Oh, you want to put it back up on the screen? Just show. Okay. Sorry, Eddie. I am going to send this YouTube link out. So if y'all want to stare at that for hours on end. All right, I'll give Eddie the, I don't know, what, 30 seconds? 10. I don't see anything on my end. I just see my screen. All right, I'm hoping that's enough time, Eddie. I'll go back and check the main screen. So one part I wish that this thing would do is, let me see what everyone's typing. Okay, okay, good, you got it, okay. All right, anything else I can do? Or should we all get our beauty rest? Number 21, Part B. Yes, I'll go look at the question, but if you're multiplying by x, you can always divide it out. But let me run over to 21. Let's see, 21. Yes, you can divide out. Anytime you're multiplying, you can divide out. So if I gave you, what's a squared b cubed c to the 4th, and divided that by a b squared c to the 5th, something like that. Here I got a squared up top. I'm dividing by an a, so that leaves me an a behind. B cubed over b squared, I get a b. C to the 4th over c to the 5th. There's actually more c's in the denominator, and so 4 of them divide out, and I'm just left with a single c in the numerator. So in that case, I would end up with that. So yes, anytime we're multiplying variables or expressions, we can divide them out if they have a common one.
Could you go over number 11, please?
Oh, sure. Number 11. What is 11? Ah, yes. I will beat everyone with the difference of two squares. Let me kind of erase that. Okay. So the pattern that I'm expecting us to know backwards and forwards is a squared minus b squared is a plus b and a minus b. Okay. So in number 11, kind of put the a's and the b's underneath it. In this case, I see that a happens to be equivalent to x plus y, and b happens to be equal to z. And so using this difference of two squares pattern, I get the first statement plus the third statement, and then I get the first statement, x plus y, minus the third or the last one. But it's just an illustration of difference of two squares. Just has more letters with it, but that's the idea that I'm trying to get you guys to show. And I will definitely put some creative difference of two squares on this test. Okay?
Thank you.
Oh, no problem.
Mr. Sally,
Yep.
out to the side of that one you had prime. What did that mean?
Oh, in the, we can put that back up. So in the test review, the question got brought up, what happens if there's a plus in between them? And the answer is we can't factor it. There is no factoring pattern for something like that. So prime is simply the shorthand way of saying not factorable. There's nothing more I can do to that question.
Okay, thank you.
Uh-huh. All right. 5 minutes till we all turn into pumpkins. No, anything else I can help with? You guys seem less stressed about this test, so.
Did you see Valerie's request up there?
Oh, did I?
Yeah, she said, can you give us a random question to solve just to test me?
What is the meaning of life? No. How about number 12 before I start making up random? Sometimes if I make up random things, they end up not being pretty and nice. But I can look at number 12. Ah, the exponent stuff. Well, that's one I can make up some numbers on. So let's see. Let's do something like 3 to the 5th times 9 to the negative 3. And I want to simplify that down as far as I can go. Okay, so first question is, what does the negative exponent mean? I mean, how can I make the negative be a positive thing? And if I just move that into the denominator of the fraction, all of a sudden it flips into positive mode. And then the other thing I'm going to notice is that 3 and 9, I can convert 9 into a common base. So I can rewrite 9 into 3 squared to the 3rd power. And so this is 3 to the 5th up top. Our exponent rule says if I have an exponent raised to an exponent, then I'm going to multiply those together. So that gives me 3 to the 6th. And so I got 5 3s, so 3 times 3 times 3, and 5 of those up in the numerator, and I have 6 of them in the denominator, so there's more in the denominator than the numerator, and 5 of them will divide out, and that will leave me with 1/3 in this case. So you'll have 2 questions, like 12 and 13. One of them will have numbers, like number 12 here, like the one we just did, and one of them will involve variable expression, so something that you can't visually see or type in a calculator, but something they have to use exponent rules to kind of simplify. So hopefully that helped.
Okay, so next to number 13, it looks like it says extra. Was that something that y'all did just for extra practice?
Yeah.
Okay.
Yeah. So someone said, "Hey, can we do another one of these?" And I went, "Sure. Here's another one." Anyways. Kind of see if that helped. So that hopefully, Valerie, that was enough of a random one to test you on. Or I mean, if you have a particular area you want to look at, we can. Or anywho, probably got time for one more because oddly enough, I always schedule these meetings back to back. Any last requests other than good luck? You guys are doing awesome. Oh, Karen, no problem. I'm glad you showed up. I was getting worried about you there. Lots of emails. I'm like, oh no, I don't know where she is. And apparently you guys all figured out how to message me and start one of these things on without me. So that was kind of cool. Anywho. All right, well, we'll just call it a night. I'll post this very exciting YouTube video on Blackboard, so if anyone wants to go back and relive the past hour, they are more than welcome to. Oh, got a question, Diego?
Yeah, quick question.
Okay.
The reviews on my math lab, do those count towards the grade? Or are they just
No, the reviews are just more practice.
okay.
Kind of like Valerie's request to have more things to practice on.
Okay. Just making sure.
Yeah. No, I don't. I mean, I don't know. I since I haven't been giving a grade for it, it just wouldn't be fair for me to all of a sudden go, okay, it's going to be very important. I mean,
Right.
you guys are taking a test. You do whatever you need to do to study. So.
Okay. Thank you.
No problem. No problem. All right. Well, y'all have a lovely night. And if you have any questions, just email them to me, and I'll make you a video or something. And if not, I will see some of you at North tomorrow, and I'll see the rest of you at Central on Saturday. So have a good night.